To the channel. So today the problem that we are going to solve is balanced binary tree. You can see the problem is very simple. It says that given a binary tree, determine if it is height balanced or not. If you don't know, binary tree is any tree with having two child nodes. So every node in the tree will have maximum two child nodes. So that is the condition for binary tree. Now if we go through the problem statement, it says that it should be height balanced. Now by height balanced, it says that for any given tree, like over here, if we say that, okay, just like this, just a second. Okay, so over here the height of the left subtree should be not the, okay, so we have this child node at the left, we have the child node at the right. What is the height at right? So this is 1, let's say this is 1, and what is over here? It is 2. So it says that difference of these left and right nodes cannot be more than 1. Got it? So if I say that absolute of height difference should be less than 1, less than or equal to 1. This is our condition of height balanced. Now very simple approach. When we see the problem statement, it's very straightforward, that given a binary tree, for every node we have to calculate the height of the left, height of the right. Am I correct? So height left, height right. Now if we think about this, first we are traversing the array, then, so what do you think of this? Can you get an intuition of recursion over here? Am I right? So what will you do? You will create this, you are given is balance. For is balance, you will check for is balance left, is balance right, and you'll also find height left, height right. Now get the difference of this height, difference less than equal to 1. If this condition is true, we are gonna say return, suppose let's initialize with b1 and b2, return b1 and b2. So by and we say both of them should be true, and otherwise if this is not true, we are gonna return false. So this is something that you can clearly see. But if we think about the solution a bit more, what do you think? What is the time complexity of this? So over here, if I say of this binary tree, so for this node we are calculating the height for, I'll change the color just a second. Yeah, for this node we are calculating the height this, then we are calculating the height this. Okay, now for again this node, then we are again calculating this height. again this and this. So can you check for redundancy? Now if you have thought so, let's go down and check what are we doing. We are calculating the height, and for that we are traversing all nodes. Am I correct? Now while calculating this, can we parallelly check balance condition? Yes, we can definitely do so. We can parallelly check this balance condition, and if we do so, our time complexity will become O of n. Now let's see how this looks at code level. Over here, what we need to do, we need to calculate the height function. So what will be our height function? So def height self and root. Now if the root is none, suppose we are the last element, then return 0, because there is no height right now, we are returning 0. Then we need to calculate the height of h left, that is again recursion root dot left, then h right, that is height root dot right. Okay, now we have to return max of h l height left height right plus 1. Now this will give us the height, but we also thought of one more thing. This is our first solution of O of n square, but can we actually check the condition over here? We have the height of left and height of right over here itself. So can we check it? If h of l is, I should say, if absolute of h of r minus h of l is greater than 1, then return minus 1. Am I correct? Because once we are returning minus 1, it says that we are actually, the answer is false. We cannot return false because we are actually dealing with integers and we are spitting out height. So now we in the is balanced array, what we are gonna do is we are just gonna call the height function for the root. Now when we are calling, we have to take care of this initialization over here as well as over here. And over here. Okay, once we are done with this, we are gonna say that if the height is coming out to be minus 1, return false, else, or they directly write else return true. Now there's one more thing to catch over here. Now let's just try and run it. Oh, everything is passing except for one use case. Let's see how we can solve this. Over here, if I just paste it, yes. Now let's see how the graph looks like for it. So 1, then 2, 2, 3, null, null, 3, then 4, then null, null, and then 4. This is the graph that we are talking about. Now if we go over here, let's assume there is null over here and there is none over here. Now while we return from here, I'll just change the color. Okay, Now once we are returning from here, what will be the output? Height 0. Same for here, 0. Then from over here it would be 1. Then, and make sure that over here also it is 0. So over here also it is coming 0. Now from here it is none, so it is 0 again, but from this side it's 1, so the difference is less than 1, so we are actually passing. But over here if we say it is coming 2, but from here it is coming 0, so what do we mean? It should be -1. Same problem over here. When we reach over here it's like 1, 2, but from here it is coming as 0, so it becomes -1. Now these two -1, actually -1 minus of -1 actually turns out to be 0. So because of this we have a condition to check for -1 not 0. But why is it coming? If we actually check over here, or h of l equals to -1 or this, then it should actually return -1. If any of the left or the right height is -1, it should return -1, and hooray. So we are completely passing all the test cases, and this is the solution that will be done in O of n time complexity. So great, I hope you like the solution. See you in the next problem. Thank you.